All right. Well, today we have a presentation from Pavlo, and I will let him introduce the topic and we'll get started.
Sure. Hey everyone, my name is Pavlo, and today I would like to talk about analyzing Android app binaries, and more in particular, how to do some reverse engineering of Android apps. I think we can get started. Yeah, just before that, a few words about me. I'm Google Developer Expert for Android, and I also currently work at a mobile infrastructure team at Lyft. Doing some interesting infrastructure work. So yeah, about the agenda of this talk, we will first see like what do the Android packages look like inside, how to read their contents, and by packages I mean like APK files, AR files, so different kinds of Android package files that are being libraries or like as installable binaries. And moreover, we'll see how to reverse engineer Android apps and how to deal with those package files and get some pretty interesting use cases, get their internals, and maybe even do some changes and rebuilding the application. So okay, yeah, let's first start with Android package files. So yeah, as we know, we have those APK, AAB, AR files. So all of those like Android-related files, uh, but basically what those files are, they're just zip files. And even though they have some fancy extensions, knowing that they are zip files, we can do some pretty interesting analysis of these files and get some information that we need. And without like further ado, I suggest just to jump to the demo and see how it works in practice. So today we'll be working with a sample application that can be found on GitHub. I will share the link, the last slide of the presentation. So basically, this is kind of image viewing application, which has a bunch of modules like so in context of this presentation, I think it doesn't really matter what exactly the application does, but the point here is that we can have kind of imitation of a complex application, which consists of many modules. It uses like Jetpack Compose and all the fancy stuff like Dagger and others. Yeah, so we have this project opened in Android Studio. So we can see here the app module, common module, and some many more modules. So what we will do, first I will just launch the application and we can verify that it works. So the idea of the application is pretty simple. We can just type this as like a suggestion it shows, and it just shows us a bunch of images. Also, we can just click on another page, which is kind of my profile. Yeah, so unfortunately, some image is not loaded, but probably this specific profile that was randomly selected. But overall, yeah, this is kind of profile page that you can check. And also, if you click on somebody else's profile, you can see that you can take a look what images this person uploaded. So yeah, so pretty simple application. And with this application, we will take a look how to work with it, how to reverse engineer it, and how to analyze its binary files. So what should we do? We can go to the build function, and we will build and generate actually signed APK file so that we can work with it. So we can click generate APK. We will select the APK file type. We will use some signature signing key. I have the test one generated just for the purpose of this talk. So we will select the release one, and it will do some building for us. Yeah, so now where we can find it, we can go to app, release, and we can see that we have two new files. Maybe I can, yeah, but basically we have two files, and we can see that this APK file is something that was just generated. So, okay, as we mentioned, this is a zip file. So what can we do with it? We can open this directory in Finder. We will go to the release. Probably I'll expand this. Yeah, so we have this APK. We can copy this file and paste again. We can name it like app release. We will mark it as APK file. And here we will change this extension to zip. We will now confirm that we want it to be as a zip file, and we will just expand it. And as we can see, we have a directory. And in this directory, we have a bunch of files. We have an Android manifest. We have a bunch of assets. We have some like resources, for example. Yeah, a bunch of resources that are also added by default. And our source code is shipped as DEX files, files with extension DEX. So yeah, this is basically the main structure of the APK file. And if you go back to the presentation, yeah, so moving back, this is APK files. However, also, as we know, there is a new format of a package files for Android, which is Android application bundle. And this file has an AAB extension. So what can we do? We can generate another signed bundle, select Android app bundle, again, sign it, release. So now we will need to wait until it's built. And if we go to the Android Studio, we can see here that now we select this AAB file. So we can do the same thing. We can go to the Finder. We can select the release folder. And we can see this AAB file. So we will copy it, paste again, move it to the release directory.
And AAB files are the recommended, in usually the recommended format, correct, for Google Play?
Yeah, and we will see. Yeah, let's replace it. Yeah, I will do the following. I will do it AB, rename it to zip, and still I will paste it. We have this zip AAB file. Yeah, that's right. This is a recommended way to do this. And now we will take a look. Why is it so? So we have this app release AAB. And when we have this thing called base. So again, we have DEX files here, which represent our source code. We have manifest, and we have resources. And we have a bunch of more metadata. So why the application bundles are better? Because usually when we have APK, we bundle there a lot of resources, a lot of different like strings or maybe like images, stuff like that. For different screen resolutions, we bundle strings for different translations. And what happens is that when you download this APK on your device, it contains a bunch of data that is not applicable to the specific application. Because, for example, if you have a specific resolution of a screen, you don't need everything else. But unfortunately, APK itself, it ships with all of this. So what AAB or like application bundle does, it instead it provides a bunch of small APKs. So the main one is base APK, which is in this base folder. This APK, this like sub APK, we can call it, it contains the source code and like the resources which are applicable to like general cases, to like every type of application. However, when we on the Play Store, when the user downloads a specific application, the Play Store figures out which resources needs to be shipped to that specific device, which strings, which images, etc. And it creates a bunch of small APKs inside of this bundle. And basically the point here is that the user has only the data that they need and nothing else, and nothing exceeding and like extra that is not used. So generally, in order to save space and make application more lightweight, it's recommended to use Android application binaries bundles. And in this way, it will take less space. But overall, like in general, in order to save space even more, it's important that those images, for example, assets, like maybe some audio files and stuff like that, it's important to make them as small as possible, which will, in addition, improve the like overall space and reduce the space that the application takes on the device. Yeah, so here we saw like the contents briefly of those APK and AAB files. However, what if we want to do something more? So, for example, what if we want to see what actually the source code of those files was? And if we just can see, like, for example, open AAB file, all the source code is packed and compressed, like shipped as a DEX file, and we don't have tools like for now how to work with it. But there is a way out of this, and now we'll see how to actually reverse engineer Android apps in a way like to see what source code is written there and maybe even how to change it. And to do that, we have a bunch of tools. So first, we have an APK analyzer, which is a default tool provided by Android Studio. We will now see how it works. Then we have dex to jar. So dex to jar allows us to decompile dex files into jar files. And then when we have those jar files, we can use another application called GD GUI. And we will be able to decompile those jar file and like see the source code that was written, well, almost written. It will be not the same code as developer wrote, but it will be representation of the bytecode that was created from that source code. And finally, we have a bit more flexible tool that allows us to dig deeper even more into what's happening in the app, APK tool, and we will see how to work with it. So, okay, let's start with APK Analyzer. So to work with APK Analyzer, we can go to our Android Studio. Let's clean up all the release directory, and let's just quickly regenerate, for example, APK file. Should be pretty quickly, and then just for sake of demonstration, let's also generate an Android app bundle file. So we have two of those files, APK and AAB. What can we do here is that we can double click on APK file, and Android Studio will just show the same file context that we just seen in regular Finder, right? So we have this resources directory with a bunch of images. We have some metadata. We have Android manifest, which is kind of readable because by default it's not readable. So it's good to have this in a very like good format that can be seen. Uh, yeah, and we have those DEX files. And when we click on those DEX files, we are able to see the actual contents of it. So for example, our application sits in the COM. Our application sits in the classes2.dex. Then we get to COM, application package. And for example, we have main activity. When we click show bytecode, we can see the kind of bytecode that generated from this class. And we can see a bunch of some Kotlin metadata because it's Kotlin code. But the problem is that, I mean, it's good to have an idea about the bytecode, but we don't, it's not the most readable format. And if we want to have a brief idea of how the application works, it may be fine, but overall, it will not bring us too much detailed information. But since even though with this approach, we can still analyze some bytecode related to each file. And similarly, it works for Android application bundle files. So I just opened AAB file. Similarly, we have this base directory, which represents a base APK file bundled inside. We have those DEX classes, classes.dex file, and we also can see the source code of our application. Like for example, let's show this class. Yeah. So this is pretty interesting tool also because it shows the size of files. It shows the download size because overall download size will be smaller due to some compressions and some other stuff. Or you can see also these red bars on the right side, which just show the percentage distribution of the size of the file, different contents of this package, which can be pretty useful just to analyzing how much space the APK takes. Especially this is important when working with some resources like images and stuff like that, like drawables, for example. Here, yeah, we have XMLs, and yeah, we should have a bunch of PNG files in other places. Yeah, so overall, it's a pretty handy tool, but while it gives some information, it does not provide all the necessary information for us that we need if we want to dive deeper into the contents of APK files. So what we can do, we can, we can go here. This was APK Analyzer. Yeah, we just seen a demo. And the next tool is Dex to Jar. So Dex to Jar helps us to get more idea of what's actually inside those DEX files, right? Because we so far we've seen on the bytecode representation of those files, but actually we can decompile it to some meaningful Java code. And let's see how it can be done. So yeah, so first, in order to work with Dex to Jar, this is like a third-party tool. We need to install it. We can install it with Homebrew, or maybe we can try another approaches. Then what we need to do, we need to run this command d2j dex to jar on the APK file that we already have. And now let's try to do this. So I have a terminal which is opened. Yeah, let me find a way to better display it. Yeah, I have a terminal which is opened in the root directory of the project. And what can we do? We can just change our directory to app release. So this is the place where our APK file is placed. And then we can just run this command. I will just copy and paste it. And we can run it. And it will start doing some work. And basically what it's doing is that it generates us some jar, like Java files that we can then use. So if we go back to Android Studio, we can see that we have a app release dash dex to jar.jar. So this is a jar file that we can work with. So what can we do now? We can use the next tool, which is called GD GUI. So this is a kind of application that allows us to open those jar files and see their contents. So yeah, it can be downloaded from the internet, just like it can be found pretty easily. And when we install this application, we might want to run it. And usually what might happen, we can see the error, which is like error launching GD GUI, no suitable Java version found. But not to worry, this actually can be fixed pretty quickly. What can be done here is that we will open the file where it's defined, show package contents, go to contents, and we have this info.playlist file. We can open it with any text editor we want, and we can see a bunch of like XML code. If you open it with Xcode, I think it will be more to show more meaningful information, but nevertheless, we can scroll down to the very down, and we can see this JVM version property. And what we need to do, we have this like 1.8 plus. In order to make this work, we can just replace it with 1.8.0. So we have this change. We click in save, and we can close this. Then we can just open the app again, and it works like a charm. So yeah, we have this app, and now what we need to do, we just need to open the jar that we just generated. So I will just go to projects. Yeah, this one. We have our app directory, then release, and we have this app release dex to jar file. So when we open it, we can see that something was opened. And if you go to the right package of our application, so now in our case it's this package, and for example, let's say we want to open main activity. We can see that we have a main activity.class file, and we can see a bunch of some code. And most probably this is not the code that was written by the developer, because just to confirm, I can return to the Android Studio. I can go to the sources, and I can open the main activity. So it's pretty small class, right? A few lines of code, just like some base Jetpack Compose setup to start the UI, which will be implemented in different modules. But what's the reason and why is this file so much larger, right? We have this metadata annotations and stuff like that. The thing is that we in the application we wrote a Kotlin code, but eventually this file shows a class file which is decompiled to Java code, because this is something that usually happens with Kotlin code, because its bytecode representation in Java looks a bit different from Kotlin, right? And in order to double check this, we can do the following. We can have this our Kotlin code in the IDE. We can double click on Shift, and we can write show Kotlin bytecode. So IntelliJ has this function which can show you the bytecode that is generated from the entire code that we just wrote in this file. And we can click the decompile button. And as you can see, it shows some code which is larger than what we wrote. It's definitely not the identical to what we just decomiled in the other application, but we have here in the IDE we have the access to the source code. But there we just decompiled it from jar file, which also adds some complications. And all those metadata and stuff like that, this is purely Kotlin stuff to make sure that Kotlin is compiled in a correct way to Java. And yeah, this might introduce some complications because sometimes it's not very easy to read and understand this code. Yeah, but unfortunately, this is how it looks like, and this would be much harder to decompile it to actual Kotlin code. So it's something to keep in mind when working with Kotlin code specifically. Yeah, but still we can have some idea about what's happening in the code. And as you can see, especially it's a bit complicated with those compose files, because as we know, the composable annotation generates a bunch of code under the hood with the Jetpack Compose compiler plugin, which also should be taken into account. All right, so we just see how JD GUI works. Yeah, so with this application, we can see and decompile the contents of the IPK file and see what's happening inside. So now we will take a look in the other application. So let's say, what if we want not to just see the contents of our IPK file, but also edit them? And there's also a handy tool for that, which is called APK tool. And generally, this is a tool for reverse engineering of Android applications. And again, to install it, it's pretty easy. We can just use Homebrew and install this tool to our machine. And then we have this command, APK tool D, which just decompiles the APK that we have. So I will again copy this command.
So this doesn't come stock with it, Android Studio. It doesn't come with it, correct?
Yes, that's correct. So this is a third-party tool, yeah, and that's why we need to install it separately in addition to our Android Studio. Yeah, that's right. Yeah, so, and again, it's pretty easy to find in Google. Just like type APK tool, and the first page will be the official page of the tool, which will show some documentation. In this case, we can use APK tool and the D command, which will decompile the APK. I can just copy this command. I can then go to the terminal, and I can paste this command here. So as we can see, we are in the release directory, which holds our original APK file. And we can, yeah, and it's done some job. So if you go into Android Studio, we can see this newly created directory, which is called app release, the same as APK was called. I will close everything else. Yeah, we have this app release directory. And as we can see here, you can see a bunch of files like Kotlin, like here. We have also Dex files, which we can open and see their content. And yeah, so basically, Android manifest, which is not very readable, but yeah, actually it should be, I guess, but I think what can be done here, uh, this command actually might be a bit written a bit different. So as you can see, those like options, they can introduce some changes to the way how we decompile here. So in this case, we didn't decompile the classes.dex file, so we haven't touched the source code, but we can change it and we can use this command again. Before that, I will just delete this directory. Let's try again, but this time we'll remove everything else and just use a d command. And as you can see, it takes a bit more time, but it does something now with classes.dex files. So again, it completed its job. We can go back and we can see app release directory. So now, as you can see, we don't have those dex files. However, we have something called smelly, like some weird name, and we can open this like this classes too, which represents like the second dex file. We can again find our application, like for example, our main activity. As you can see, it has a pretty weird extension name. And here it shows us the same like bytecode as we've seen in APK tool. But what's interesting here is that we can change this bytecode. And for example, what we can do now, we can see how we can like decompile the application, which we just did with APK tool. Now we will do some change to the source code of application, and we will build it again and launch on the mobile phone, and we will see that this change was actually included in the new APK. So what we will do, as you can see, we have this profile screen, which has the title on top of the screen, which is called profile. So for a simplicity of demonstration, let's just rename this title to something else, and let's see how it can be done with APK tool. So in order to do this, we need to find the corresponding file that has this profile string. So we will open our application package. We will go to profile. It's this file located something here. So it's user profile view model. And as we can see, we have two titles, my profile and profile. So profile is when we open profile for some other user, but what we can do here, we can click to this and we can see a my profile. So let's change the string. Let's say my updated profile and just like updated profile. So now we've changed those strings, and what should we do next? So optionally, we can, for example, go to Android manifest, which is now readable because we told APK tool to decompress the APK, manifest contents. For example, can change like contents, different parameters of the manifest file, but we won't do it now because for the sake of demonstration, I think the profile title will be enough. So yeah, we've made a change. What can we do next? We will go to slides. Yeah, we just made a change, and we will use another command, which is called b or build. We will insert it here, and let's start building. It will take some time, not very long, but yeah, it needs to again generate dex files from those like smally files. So overall, the smally filing stage extension is some human readable representation of the Java bytecode. So it's kind of like a language that's is an intermediate representation of a bytecode, just to make sure it's easy readable. So okay, it's completed its work. And now here we have a new directory. In this directory that we just edited, we have dist, and we have a new APK. But this APK is not yet ready to use because we also need to sign it. And this signing process is pretty straightforward. So first, we need to generate our signing key. So like the flow is the same as we would usually do the application signing in terminal. We'll do it in terminal because we already have an existing APK, so we need to make sure we will sign it instead of creating the new one. So I will not run this command because I already have a test signature key, but then I will use a jar signer tool to sign our specific APK. And as we can see, we are just specifying in which directory this new APK exists. And we'll just write, I'll just copy this command and then insert it here. And let's run it. Yes, so I will write the password. Probably the password is invalid. What happens? Oh, okay, that's weird. Oh, no such file or directory. That's interesting. I will do the following way then. I will just create a new key. Not sure what's the problem, but that's happens sometimes. Yes, so I'll write the password. Okay, my name. Yeah, you can skip all of this. Maybe yes. And we just generated new key. Let's try this again. Here in the terminal. Yeah, just need to make sure it's the right. No, this I need to copy this one. Okay. Okay. Some technical difficulty, but now it looks to be fine. So we signed it. We can also verify if it was signed correctly. Again, with the jar signer, we can just run it verification command against the newly generated APK just to make sure it's correct. So I'll insert this command and run enter. Yeah, so looks to be fine. And just to verify it, let's run it and install it to our device. So I will delete this APK that we already have. And here we have this APK, it's already signed, so let's install it. It was just successfully installed here in this message. And let's run the application. Okay, we just launched the application. And let's go to the profile. And as we can see, now we can see the my updated profile string here. And here we can write Ethan, for example, just to load some images, and let's open some profile. And as you can see, it has updated profile. And this is because we edited the corresponding file. Again, I'll open it here, profile, user profile view model. Yes, so we just updated those files, and after compiling all of this together back to APK.
Yeah, that's pretty cool.
Yeah, it's pretty fun stuff. However, there might be problems. So as you might notice that, I mean, it's easy to edit the string, right? Because I mean, this is a bytecode representation. So if you want to do something more complex, it would be hard to do it in bytecode. And yeah, that's the problem. So those approaches would be easy to just edit some strings like resources or stuff like that. If you want to edit the code, the process might be more difficult. We will not go through the actual process of doing this. However, I want to point out and share the pretty nice Stack Overflow thread here, which is like decompiling APK, modify and recompile. And here is a nice answer. So what we can do here, I just want to share it and give the credit to the person who shared it. We can use dex2jar tool, and with GD GUI tool, which we also used, we can convert jar file back to Java files, and like regular Java files with some weird code, but it still will be Java files. Yeah, with APK tool, we can decompile the APK and get the manifest and resource files. Then we can create a new project and then add those resources and manifests from our original decompiled project. Then this is the tricky part. We will paste Java files extracted with our GD GUI. However, the problem if it's a pretty large project with like hundreds of thousands of Java files, yeah, that might be not very straightforward. Yeah, but at some degree, this approach will allow to do some modification. Yeah, but obviously this is not the most pleasant way. Yeah, but if there is some such task, I think yeah, at some degree it can be done. Uh, yeah, and yeah, so that's pretty much it. I think just one more thing. I just want to share uh, the source code of the project that was used in this demo, just if anybody is interested. And I think that's it. Thank you for watching.
Cool. Yeah, I just had one question.
Yeah.
Um, so making this change, you're modifying, you open an APK, you unzip it, you make some changes and rebuild the package with a key and sign it. Is there an easy way to know whether an APK has been modified based on its original APK? I mean, perhaps they use a different key, or is there like a hash or a checksum to compare?
Yeah, that's a very good question. Yeah, and I think the key here is the signature key that like it's also been verified by Play Store, for example. Yeah, so uh,
Hmm.
if you, for example, use the same signature key that is used on Play Store, you can just sign the new APK with it, and it should be fine. For whatever reason you might want to do it. Yeah, but Google, I think, made this pretty safe that like if you're using another signature key like I just created, right?
Right.
So it will be easy to verify that something is wrong and this is like not the native APK that was originally created.
Which is one of the benefits of Google
Yeah,
Play is they have these things in place to help protect your apps.
yeah,
Yeah.
for sure.
Yeah, I can see this being useful. Perhaps someone working in a company and they have to test against a release build, and
Hmm.
perhaps they just take that release build and modify perhaps a URL or something
Yeah.
to mock endpoints, possibly, or to help with logging, and just repackage it again for testing a release version. I can
Hmm.
see that being helpful.
Yeah, and definitely like even on the websites of those tools, it's like explicitly mentioned that I mean because it's when you see those tools, you kind of they imply some harmful usage, right? But it's
Right.
intended also to some positive like use cases that do not bring harm to users or like to
Hmm.
publishers of the app, which is also very important. Yeah.
Yeah.
But also one more thing is that yeah, you mentioned right that those use cases, for example, when you have some hard coded URL, maybe like you can change them. But yeah, as we just saw, like it's not it's impossible to clearly decompile the code to the original Kotlin code because like if you're using Kotlin, it brings some additional complexity. Yeah, but at some degree you
Right.
at least
Hmm.
might have an idea what's happening in the app. Yeah, but it's not perfect, definitely.
Yeah, and things like comments are stripped out. You lose the variable names and a lot of things.
Mm-hmm. Yeah,
If
that's
you
right.
use also, I don't know if you touched on this, but using ProGuard could also
Yes.
change the legibility of that as well. You'd have to be able to associate it with I forgot the name of it, but to be able
Yeah.
to really compile those, you'd have to have special files to do that, right?
Yeah, that's right. You would need to like run this code against the ProGuard mapping files, like yeah, to decompile them to the original uh, look and feel. Yeah, which is additional complexity. Because like when just from experience of working on large project like consists of like millions lines of code, it would be really hard like to do it very productively, like to work with those mapping files and get everything together, like decompile, compile back.
Hmm.
So yeah, this process definitely is not perfect, but at least it gives some flexibility and some opportunities to work.
Yeah, very true. Great. Well, thanks, Pablo, for all of this work and information. And yeah, I appreciate all the information that you've shared and how to go through this process and the implications and what it can mean. I mean, for good purposes too, not just malicious intent, but there's some positive use cases as well.
Yeah, sure. Thanks a lot for having me.
All right, thank you so much.
Thank you.
All right, we'll see you.